Welcome to another video of line 75, and we're focusing on the second problem in the two pointers thematic group of the 75 problems. In this particular problem, we are given an array of integers called numbers that is sorted in non-decreasing order, basically. We need to return the indices which of two numbers, index 1 and index 2, such that together they add up to a given target number provided to us. We need to make sure that index 1 and index 2 cannot be equal. Therefore, we cannot use the same index twice, and our solution must use the O1 additional space, basically. And there's only one exactly valid solution in this problem. So there's no more than one solution on this problem that we can work with. So with that out of the way, let's focus into this problem first. So first of all, I think we need to understand what we need to do in this problem. So if you're given let's say a group of numbers, let's say 1, 3, 5, 7, right? Let's just use these four numbers. We're given a target number of let's say 8, right? So what this formula needs to do, it needs to add numbers together. For example, if we go with a very simple and brute force method, we select 1 first and add 3 to 1 first. See if the total is 8. It doesn't come out to 8, so we cross that out. Then we go and add 1, 5 to 1. Does that add up to 8? No, it doesn't. Cross that out. Then we go to 7 and add 1 to it. That should be 8, right? So that is the correct solution. Mind you, I think mind you, I think let's make this 4 instead of 3. We don't have multiple multiple correct solutions here. So let's make 4 as the number here. So potentially that is the correct solution, and potentially because only one solution is needed, as long as that solution is correct, we're good to go. But let's say the target number was 12, for example, right? It wasn't 8 that we have right now, but the target number was, let's say, 12. So if we have the target number as 12 here, the issue there would be, as this would also be incorrect, mean we need to now go with 4 plus 5 and check that. That shouldn't give us the right answer. Then 4 needs to check with so then 4 needs to check with 7. It would not give us the target correct number. This would be wrong as well. And then 5 would check with 7 directly, and that should be the correct solution. And the output that will be giving out in this answer would be index number of 5 and 7, which are 0, 1, 2, and 4. So that would be our output number for the index, right? 2 and 3, right? And that would be the answer, correct answer for this. But this problem is brute forcing our way through the entire problem. We're going over each and every number in the index to find our solution, which means the solution potential time would be n steps into n, which would mean we need to do n steps for each element of the list, so n into n. So our O of n time should be n squared, right? So what does that tell us? That tells us that this is not the solution for this problem. Using this brute force mechanism is not how we're going to solve this problem. So how do we solve this problem? Potentially, the best way to solve this problem is pointers. And as we have discovered pointers previously, let's go back to this here. So let's say we have this in index in our in our we have this list of numbers as our prompt basically, and our target here is to find the target number of, let's say, 9 again, right? So we need target number of 9. So how do we go about it, right? One way could be, and that's the way we're going to, like, there are multiple ways, but we need to use pointers, right? Pointers are specific specific mechanisms that point to certain indexes, right? So we have 2 pointers here, and both on the opposite spectrum. So what do? Is we add both pointers. Let's say, let's call this pointer. Let me change the color of these, red, and let's make the other. Let's say, yeah, let's just use green, right? So we have a green pointer here. So we need to basically add these two together to find our answer. We need to add these two together to find our answer and reach this target number of 9. So how do we do that? So 1 plus 11 should be 12, right? But 12 is not the answer, or that not the number that we're looking for. So what does that mean? We need to we need to shift one of these 2 pointers and try the sum between these two, because we need to sum these two together to test whether we have the correct we have the correct pointer or not. But to do that, once we've done that, we need to first identify which pointer to move, right? So in this case, as 1 plus 11 equals to 12, and 12 is greater than our target number here, right? It's greater than our target number, which would mean we need to move the bigger number here. We need to move the bigger of these two, and the bigger is 11, so we move 11. So we remove this here and move our pointer to second place here, right? So again, we add 1 plus 10. The answer is 11, which is still greater than 9. So we move our pointer back to here, right? So now 1 plus 7 equals to 8, right? That doesn't make sense, right? So this means now in this case, our value 8 is less than 9. And when we are less than the number there, then we need to move the value on the left to the right. So we the pointer moves from here back to the second place. Sorry, I'm using the wrong here. Back to this place basically. When we move back to this place, we do the summation operation again. 3 plus 7 equals to 10. That is larger than the target number. So again, this pointer here on the right moves one step to the left, basically, right? And at that point, the answer should add up to 9. In this case, this should add up to 9 at all case, because that is our presumption. Let me actually correct this. I think the number here is incorrect, but these are arbitrary numbers that I'm using to demonstrate the concept regarding these problems. So there could be some numbers that are not up to par. So presumably this is 6, right? So 6 plus 3 equals to 9. So this is the correct solution right here. This is the solution we needed, right? We found that solution. And if you have one solution left, that should be the answer for your problem. Otherwise, the data input for numbers is incorrect. So now that that is the correct answer, we select the index values of these two places, which is 1 and 2, and return that as the output of this problem. That is basically what we need to do in our code to solve this problem. Now that we have a basic understanding of what we need to do, let's move back to our coding and start coding this problem out, right? So potentially, let's let's rehash out this problem and break it down again. So what we need to do in this 2SUM2 problem is to use the two-pointer technique to solve this problem, which is especially suited when we have a sorted array. That is a point to remember for any other different question, is that when you have a sorted array, two-pointer technique is a well-suited technique to work on that. If two numbers can move, if the key insight that we developed from our explanation just right now is that if the sum of the two numbers is too large, then we move the right pointer to the left, and if the sum is too small, then we move the left pointer to, as we did previously in the visual explanation that we just went through. Our approach is going to be quite simple. First, we're going to create two pointers. One pointer starts at the beginning of the array on the left side, which is the left pointer, and the other, which was the red pointer on our explanation, and the other pointer starts at the end, which is the right side, which is the green pointer in our. At each step, we check if the sum of those two numbers at the left and right point matches the target. Sum is equal to the target. We return the indices, one indexed. So I think I was indexing them a little bit inappropriately in our explanation, because we were indexing them based on the zero indexed common sense indexing in computer science. But presumably we need to one indexing. So when we talk about one indexing, as in the problem, so potentially here we gave the answer as 1 and 2, right? But that won't be the case. So as it's one index, so this is going to be 1, and this is going to be 2, and this is going to be 3, right? So our output is going to be not 1 and 2. Our output is going to be 2 and 3. So let's correct that just so that we know, and we write that down here as 1 indexed. So we know that we're indexing based on not the natural state of programming languages in computer science, but based on requested state of one index. So we set that up like this. So yeah. So now that we've clarified that misconception earlier, so but at that point, if the sum is less than the target, then we move the red arrow to the right to increase the sum. And if the sum of the target is greater than the target, then we move the green or the right arrow to the left. We need to ensure that the linear time complexity in this problem is O of n, with O of 1 as additional space. And that is only possible through these two inner pointer solution to this problem. That out of the way, let's start coding it out. So first, we need to write down the two indexes and their positioning. So we'll get started on that immediately. So we move back here. So we write first as the left index and place its value at 0. Place its value at basically -1. That should place x value pointers need to start basically, right? After that, basically we need to have some control. So when we're working with two pointers, we always use while loops because we need to keep the pointers moving in a certain pattern until we reach the point where we need to break out of this. Where would be that point? Where it's always, in most cases, going to be when the left pointer um, has a value greater than the right pointer, right? As soon as that occurs, we know the two pointers have intersected and crossed over in each other's domains. At that point, we need to stop the loop. So that is the first condition to break out of the loop. And until that condition is having these points until they find the solution to the problem. As long as left pointer have a greater index value than the right, we need to continue working to find the solution to this problem. Then we need to create a new variable where we need current sum. Basically, in every iteration, the sum of the value of the number that is pointed by the left pointer, which is the red pointer, and plus the number pointed by the right pointer or the green pointer. So we're going to write numbers are array of numbers at by the left, the red pointer to the number pointed by the right or the. So once we have that sum sorted, then we need to check if the current sum is equal to the target. And this is very, very easy because again, we have demarcated the three tests that we need to do with every number, right? If that is the case, we return the value. If that's not the case, we move the integer, the left integer right and the right integer left, basically, based on the situation. For example, if the current sum is greater than the target value, which means that the left side needs to be moved ahead. So current sum is less than the target value, then the left or the red arrow pointer needs to be moved to the right. And or vice versa, if basically current sum is greater than the target, then we move the green arrow to the left, or which is the right arrow as well, basically. So first we need to check if the current sum is equal. First we need to check if the current sum is equal to the target value. If that's true, we're done. We're truly done with this problem and we have our answer. But that is not the case, then we need to continue moving. Return left plus one for and right as well. We make sure that we are one indexed. The result is one indexed whenever it is returned. That out of the way, then we have the elif statement. In this statement, we check if the current sum is less than the value. Current sum is less than the target value. As mentioned just a little while back, we're always going to add value to the red or the left pointer so that it moves towards the right. So when we equal the right, basically. Then we have the else statement. No need to define any condition. If either of those cases don't work, we pretty much bring the right arrow or the green arrow towards the left or inside, which is basically with that out of the way. I think we have completed our entire problem. So let's test the solution out and see if it gives us the correct answer. And that is the case. It has successfully passed the test for this problem. And with that we have completed the solution for the 2SUM2 problem and the second two-pointer problem in line 75 questions. All right, thank you.